We're in line Y1, looking at learning task 8, which is going to be three-phase synchronous motor connections. And to be honest, it's a little bit of an oddball that they even have this as a standalone learning task, because this learning task that we're taking a look at is really just going to go and be repetition of what we covered very, very early on in here underneath my learning task number 3. Learning task number 3 had to do with the different types of connections for squirrel cage induction motors. What is a synchronous motor? Well, a synchronous motor is simply going to go and be a squirrel cage motor that also has a DC winding. Remember, we've still got that squirrel cage winding that we have inside of here that is going to go and be referred to as our amortisseur winding, right? And that amortisseur, I think that's how you spell it. But that amortisseur winding is designed to go and pick up a rotating field that is going to be generated by the stator over here, and then it starts to get this motor up close to its rotation. Once we get all the way up to rotation, excuse me, at that point, then we are going to go and kick in the DC that we would supply into F1 and F2, which is going to be our DC rotor winding, which is fed through those slip rings and brushes, and then the thing steps into sync. For our connections are going to be the same as we would for any other squirrel cage induction motor, because we have got the same type of stator that is going to be used. Ultimately, it's the same stator that we are going to use whether we're looking at a synchronous wound rotor or a squirrel cage induction motors. Always just changes to the rotors themselves. So what's happening inside of this learning task is they're just kind of re-stepping through a lot of what we had before. Over here, we've got a 6-lead motor where they brought out all of our individual windings. And once again, it's going to be windings 1 through 4 is going to go and be a winding set. Windings 2 through 5 is going to be a winding set, and windings 3 through 6 is going to go and be a winding set. And you can develop these numbers yourself anytime off numbers as well by just going and either drawing these things as a Y like that, or we could even draw them as a delta. Let me actually move this over and we'll create winding values off of these. Let me just delete that and that and that. There. But I can go and create any of my winding layouts, whether it's going to be inside of Y or delta, by just following this. If it's if I want to go and develop them off of a Y, I go 1, 2, 3, 4, 5, 6, where I'm spiraling around and then in, like that. That's going to go and get me a winding 1 through 4, same as what we see over here. Then a winding 2 through 5, same as what we see over here, and 3 through 6, like that. So when you're looking at windings, you should be able to go and create that so you can tell which windings are connected where. I could do the exact same thing working off of a delta like this, where I would go 1, 2, 3, then go 4, 5, 6. Either way is going to go and get you the exact same windings. I see I've got 1 and 4, 2 and 5, 3 and 6. Once I've got those windings, what I can do is I can go and use these as a dual voltage motor. If those were 120 volt windings, I could connect them into a delta connection if I had a 120 volt delta, or I could go and connect them into a Y connection if I have a 120/208 system that is going to be available for me. Past that, if I go to a 12-lead motor, I've got even further versatility, right? I can go 12-lead delta, parallel delta, which is going to be rated for the low voltage, whatever I've got for my windings. If my windings themselves are rated for 240, because it would be connected in parallel, this entire setup would then be rated for a 240 delta. That's a omega there. 240 delta that I would have. If I was to use the same windings rated for 240 but series them, now it would be good for a 480 delta type of setup that I would have. It gives us an increase in versatility. If we go and take the same leads, we can reconnect the same leads into a Y type of connection over here, and then we would be able to go on once again, start picking up some differing values of voltage. Over here, if I use those same windings as before, let's say that those things would be 240, I would see that I'm going to have parallel 240, so I've got a Y that is going to be made up of 240 line to line, 240 phases, which means my line to line would be a 416. So it's going to be 416, 240. And if I would use those same 240 volt coils and connect them into series like this, now I would go and have 480 that would be across from line to line, so that's 480, which would mean that I would then be taking this thing up to an 832. Oddball voltages, not really commonly used. What they're just trying to show, by having this 12 lead, is that there is going to be versatility across a bunch of different types of systems that I would go and have. They gave different values inside of your book. Follow them through inside of your book. Just know how to do connections. If I give you something where it is going to be a motor, and I'm going to go and tell you that you need to make connections. I've got individual coils that are good for 120 volts. You should be able to tell me that if my coils are good for 120 volts, and if I was to apply a 122.8 system, that you'd be doing this, the parallel Y. Or if my coils were good for 120 volts, and I was feeding this thing with a 416, you should be able to tell me that I would be doing that off of this series type of connection over here. Okay, straightforward, do the math, follow these things through, and that's it for this one. Short and sweet.